3 log base 2 of x is equal to negative 3. Then I want to divide by 3. Log base 2 of x equals negative 1. Now this is in logarithmic form. Let's write it in exponential form. The base is 2, the exponent is negative 1, and the answer is x. And so 2 to the negative 1 means drop it to the denominator, drop 2 to the denominator to the positive power, and we get x is equal to 1/2. Okay, so first of all, using the properties of logarithms, because we're adding these two logarithms, it means it must have been the product rule. So this can be written as log base 2 of the product of x minus 3 times x minus 4, and that's equal to 1. Simplifying by FOIL, I have log base 2 of x times x is x squared. The outside is negative 4x. The inside is negative 3x, which is negative 7x. And a negative times a negative is a positive. 12 equals 1. Now, similar to the last problem, I want to change from logarithmic to exponential form. So the base is 2, the exponent is 1, and that's equal to x squared minus 7x plus 12. To solve a quadratic, we want to set it equal to 0. So I'm going to subtract 2 from each side. And factor. So it's an x minus 5 and x minus 2, so that we get a middle term of negative 7x, and a negative times negative is a positive 10. Setting each one of these equal to 0, I get a solution of 5 and 2. However, I need to check, because it is not necessarily the case that both of these are going to work when I substitute back in. So when I check, I have the log base 2 of, let's substitute in 5 minus 3, plus the log base 2 of 5 minus 4 equals 1. The log base 2 of 2 is 1. The log base 2 of 1 is 0. So what we're getting here is 1 plus 0 is 1, and that checks. However, if I put in log base 2 of 2 minus 3 plus log base 2 of 2 minus 4, then I have the log of negative 1 plus the log of negative 2. And we can't have the log of a negative number. So this is not going to work as a solution. Because this is the sum of logarithms, it must be the product of x times x minus 8 is equal to 2. So this is log base 3 of the product with distributive property. X times x is x squared. X times negative 8 is negative 8x equals 2. The next step is to change from logarithmic to exponential form. 3 raised to the second power is equal to x squared minus 8x. So we have 9 equals x squared minus 8x. I'll work over here. X squared minus 8x minus 9 equals 0. We always want to have the quadratic equal to 0 before we start to factor. We're going to factor this into product of two binomials. So we have x plus 1 and x minus 9. That way we have a negative 8x in the middle and a negative 9. And we get a solution of negative 1 and positive 9 perhaps. But again, we need to check. So I have the log base 3 of negative 1 minus 8 plus the log base 3 of negative 1 equals 2. And so that's not going to work because we have the log of a negative number. Log base 3 of 9 minus 8 plus the log base 3 of 9 equals 2. So I have the log base 3 of 1 plus the log base 3 of 9. The log base 3 of 1 is 0. The log base 3 of 9 is 2, and 0 plus 2 equals 2, and that checks. Subtract 3, I have the log of 2x plus 5 is equal to negative 1. Now with no base written, it's a base of 10. So this is 10 to the negative 1 power equals 2x plus 5. 10 to the negative 1 is 1/10 equals 2x plus 5. You can put 2x plus 5 over 1 and cross multiply. So I have 10 times 2x plus 5 equals 1. Or 20x plus 50 equals 1. 20x equals negative 49. So x is equal to negative 49 over 20. Now if I substitute back in 2 times a negative 49 over 20 plus 5 gives you negative 49 over 10, or negative 4.9 plus 5, and that is positive. Therefore, I know that this is going to stay as a solution. The base is 10, so I have 10 to the 0 power is equal to x squared minus x minus 5. 10 to the 0 power is 1. So I have 1 equals x squared minus x minus 5. Setting the quadratic equal to 0, I have x squared minus x minus 6 equals 0, subtracting 1 from each side. Factoring trinomial into the product of two binomials, at x minus 3 and x plus 2, that gives me a negative 1x for a middle term and a negative 6. So I'm going to set each of the factors equal to 0 to get two possible solutions of 3 and negative 2. So let's substitute back in. If I substitute in 3, I have 3 squared minus 3 minus 5, and that's positive. If I substitute in negative 2 squared is 4, minus a negative 2 is plus 2 minus 5, and that also is positive. So both of these stay as solutions. So our base is 4, the exponent is 1, and the answer is x squared minus 7x plus 14. So 4 to the first power is 4, and we're going to subtract 4 from each side. Then we're going to factor the quadratic into the product of two binomials, x minus 5 and x minus 2, so that we have a middle term of negative 7x and the constant of positive 10. Setting each of the factors equal to 0 gives you two possible solutions of 5 and 2. If I substitute in 5 squared minus 7 times 5 is negative 10, but adding 14 is positive. 5, 2 squared is 4, minus 7 times 2 is 14, plus 14 is also positive. Therefore, both of these solutions are going to stay. Okay, so we're back to the rules for logarithms, and since this is subtraction, it must have been division. So it's the ln of 2x minus 3 divided by x plus 5 equals 0. And we know that the ln, when it's equal to 0, is 1. So we know that 2x minus 3 over x plus 5 must be equal to 1. And I just did a problem similar to that in the exponential part. I can take and put 1 over 1 and cross multiply. X plus 5 equals 2x minus 3. Subtracting x and adding 3, I get x is equal to 8. Because remember, ln of 1 is equal to 0. So that's what we're basing this on.